Okay, this is problem 2 for tutorial 2. Problem 2 is fairly straightforward. It's the only thing you have to use is you have to look at the geometry of the structure, and you have to look at the equation for stability, which is just the m plus r is greater than or equal to 2j, where m is the number of members, r is the number of reactions, and j is a number of joints. So yeah, this stuff is fairly straightforward. I'll just do the first one with you very quickly, and you guys can do the other 3. When I'm doing this, I like to I number everything as I'm working. So for example, I'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I number all my members. Let me make sure that I got the same number of members. Yes, I got 13 members. And then I number all my joints, and I circle my joints so that I can distinguish them. So I have 1, 2, 3, 4, 5, 6, 7, 8. Let me make sure. Yes. And now let's look at the number of reactions. Number of reactions, I do times. I add a little cross symbol in front of it, times 2. This is times 1. So if you have all those in, then you can tell by the equation very quickly that your number 13, number 8, and this is 3. So you have 13 plus 3 is greater than or equal to 2 times 8. This is 16 greater than or equal to 16. So the structure is determinate. Now, it's determinate, but is it stable? And that is the interesting question. I don't know how well you guys are able to read. Oh, I just looked at my screen. This was off camera. I hope everything was in frame. I don't know if you can look at this and tell whether or not it's stable, but let's just think about it. Are all the sections triangular? If we look at this here, we have a triangular section. We have one triangular section. Even though they overlap, it's still a triangular section. We have another triangular section. We have another triangular section. We have another triangular section. So we have all triangular sections. Okay. So that is a first sign that your stability is good. Now, what about this section here? A lot of you may not be happy with how this thing right here is drawn, but in actuality, it is okay. You might say, well, you don't need this. You can just take this away. And that is true. But because you'll be like, well, the member forces here are going to be 0, right? And yes, they are. But that's in this case. The reason why you might draw a structure like this is, let's say, I don't know, that you might have, for example, a point load here. And if you have a point load here, this number will no longer be 0. And for this is the main reason why you have some elements. This is the main reason why you have zero force members. You just have members that can support load, but they are not supporting a load now. So for a zero force member, you could put a load P onto it and it would still be stable, and that is the important thing. For example, here you might put a crane, for example, on top of here to allow you to do maintenance work on the rest of the truss or something. Yeah, I don't know of any other examples, but you sometimes purposely build zero force members so that you can load them in the future if need be. The other ones, I will let you know that the question asks if a indeterminate structure could be made determinate. And remember that if you choose to do, for example, this problem by removing a joint, so for example, these are connected, so you end up having, let me use the same color marker, each one of these is 4 members. 1, 2, 3, 4. And you might say, well, you can redraw this in terms of where this is not connected. But what happens? Your M goes down by 2, and your J goes down by 1. But in this equation, because you're multiplying J by 2, in reality, your equation is still, your system is still indeterminate. So, for example, this I'll tell you now, this is going to be indeterminate, but let's say, for example, that M was, I don't know, I counted it out somewhere, but I don't remember where. I believe M was 21, R was equal to 3, and J was equal to 11, so you get 24 is greater than 22. Well, if you do this, you end up getting 22 is greater than 20, and this is still indeterminate by 2 degrees of freedom. So you cannot make this determinate by just removing these 2 points. You have to think of something else to do. But yes, that is pretty much it for this problem. Again, pretty straightforward. Yeah, let us know if you have any questions.